Record. All right. So if you were bored and decided to look ahead at chapter 1, especially 1.2, that was on our homework schedule, you see we're starting functions and their properties. So this is going to feel a little more like Algebra 2. Anyone remind us what a function is? Anyone can tell us what a function is?
Is it something like a set of inputs to a set of outputs, or a relation from a set of inputs to a set of outputs?
Very
Something
good.
like that.
Giovanni? I like to use that word, relation. Right? So functions are relations. Grabs the inputs. We can refer to those as x's. Output. All those are y values. Right? Very good. So formally, we also call these domain and range. Our domain is like our x's, our range is our y. All right, everybody remember that? Algebra 1, algebra 2. Maybe do some function maps like this. So here you have your x's and you have y's. So this is your function. Right? Very good, very good. So how can we determine from looking at a graph if a relation is a function? We have this. We have this. Anybody remember a simple way to check? Like, is this a function? Is this a function? Is this a function?
Yeah, they're all functions, aren't they?
Not all of them,
Except for the middle one.
except for the middle one. So this one's not a function. Why not? Anybody know why it's not a function? Is this one a function?
Yeah,
Why?
because it has both the domain and range.
So does this one.
I don't know.
It's good. It's good. I like that you're participating. JC, anyone else? JC's not wrong, but I want to know why. I told you in my class, I always ask why. Like, hey, we got the answer. Great. So what? I want you to know why. Why is this the case?
Isn't it something to do with like the y-intercept? Or is it the x-intercept? I don't remember.
Okay, okay. So it's a long summer, right? While we review here. So kind of something to do with intercepts. Anybody remember this thing? No one remembers vertical line?
I think I know. Isn't it because like you can't have the same point on the y-axis intercept more than once?
Okay, or
Something like that.
something like that. So if I were to draw a vertical line
Yeah, there's 2 points that it intersects, and that means it's not a function, right?
across this here, but let's think about what this is saying, right? This is saying that some x value here is giving me what? 2 different y values, isn't it? So you're saying this x value could be mapped up to here, or it could be mapped down to here. So we're getting two different answers for the same x. We're getting two different answers for the same x. Well, that's impossible, isn't it? Because you know, if you have a y equals, let's do something like this, something basic, since you guys are asleep today. So if I tell you this is my function, and I'm trying to put an x in here, is it possible to get two different y values? Can I get two different answers if I put the same x in here? So what's today? Today's Tuesday. Let's say Tuesday, I say x is 5. If I put 5 here, what do I get?
8.
Someone's awake. Very good. Y is 8. Let's say on Wednesday, x is still 5. Can I get a different y value? Can y now be 6? If I put 5 here, what's 5 plus 3?
8.
8. It's always going to be 8. Right? So we need to add a little bit more to this idea of a function. So it is a relation that maps inputs to outputs, but we have to be careful. It cannot map the same input to two different outputs. And I just showed you why. It can't happen. If I take an x value, throw it in here, and I do something, then I can only get one y value. I can't get two different y values. If I do, then it's not a function. It's a relation, but it's not a function. Okay, so make sure you put that back in your brain. I know it was a long summer, you forgot. At some point in Algebra 2, you knew this. So we know a domain, range, function. Oh, we didn't really talk about range. Let's talk about range for a second. Now that you guys know interval notation, here's the confusing equalities just the same. Let's say we have an easy function. I won't stretch your brain too much. Quick, what's the domain?
0
All real numbers.
or
Remember your
Domain
domain
is
is your
all
x.
real numbers.
So this would be all real numbers. Right? And you could write it like this. So from negative infinity to positive infinity, that's our domain. Any x value here will get me to a y value. So what's the range?
Is it y is greater than 0?
Greater than or
Oh, equal to, yeah, greater than or equal to.
could equal 0. And in interval notation,
Would it be 0? Oh no, bracket 0,
bracket 0.
comma, infinity, parentheses.
Good. So in your homework, you'll be asked to do these kinds of questions. If you're given a function, and given that function, you have to identify the domain and range. So I'm not sure how the book asked for this. I think I mentioned you could do it either way on the AP Calculus textbook. I could read it either way, but honest truth, I prefer interval notation. It's just easier. Very good. So we talked about those. Now comes the fun part. Here's where you gotta wake up. Here's where I wish I could see your faces. Here in my classroom, I could just look out there and see who's confused. But we're gonna talk about continue. I think that's right. And where is it not continuous? Oh, I think Kareem's back. I don't know if his mic's working. I see it. I don't know if his mic's working. Kareem, your mic working there?
Yeah, I just had to switch over to mobile.
There you go. So continuous functions, we're going to talk about discontinuities, right? So I just erased the continuous function. So y equals x squared. This would be continuous. So continuous just means, simple definition, I can draw it without lifting my pen pencil, right? So it's continuous, I can draw it. If I have to lift my pen or pencil, it's not continuous. You're like, what? So let's look at an example where it's not continuous. So you guys have Desmos open, hopefully. So let's look at a simple one. You guys remember what this looks like from Algebra 2?
Is that one of those like piece ones or whatever?
Kind of. It's not necessarily piecewise, but it's not continuous. So if you have Desmos, you could graph it, or you could make some points in your head. It's not too difficult. Right, you can ask yourself, well, if x is 1, then y is, right?
Isn't it like an asymptote, or it creates like an asymptote?
No, we're going to have asymptotes. So when x is 1, y is
1,
1. What if x is negative 1?
-1.
Negative 1. What if x is 2?
1/2,
Yeah. What if x is 3?
1/3.
Third, and then 1/4, right?
Yeah.
And if x is 1/2, then what's y?
2.
2. And then 3, right? So you are correct. It creates these functions that are asymptotic, right? Follow the asymptote of the axis. So it can never be zeros. So does that look continuous?
No,
Yeah.
No, definitely not continuous. Why not? Look at the definition.
because you had to
They're
pick
not
it.
even connected.
I
You
can't.
gotta pick up your pencil.
They're not connected. This one should top up, this one should top up there. So if I'm trying to draw this function, I draw it here and I go this way, but I have to lift my pen to get up here and draw this way. So this is what we call, if I can spell, infinite discontinuity. Infinite because this shoots off down here to negative infinity. This shoots off up here to positive infinity. So you're approaching different infinities. That's an infinite discontinuity. Goes on forever. Okay? And these usually happen when you have fractions. So these are your rational functions. Any questions on that?
No.
touches the vertical line more than 2 times. Oh, okay. That was the last one. Just trying to catch up on your comments. Very good. You guys say your
Mr. Garcia. Since it's never gonna touch the y-axis, then is it gonna get to the point where like where it too becomes a straight line, making it like a relation rather than a function, or is that not how it works?
mean, is part of this going to become a straight line?
Yeah, or is that considered a relation or a function?
This is a function.
Oh, okay.
So this is a function. Good question. So this is a function because every x only has one y, right? There's no, it passes the vertical line test. So if you were to draw a vertical line anywhere, it only touches the function one time. So because it passes vertical line test, there's only one y for every x. This is a function. Right? So good question. Even though this is an asymptote, even though this follows that asymptote, this is still has some curvature to it. It's always going to be curved down. This one's always going to be curved this way. It'll be very tiny, but it's there. And let's do one that's a removable discontinuity. There's a fun one. I'll test your skills from Algebra 2.
I don't think we ever learned this.
How could we graph it? You never learned that in Algebra 2?
No.
You didn't do rational functions in Algebra 2? I'm pretty sure you cover rational functions in
I
Algebra.
don't think we made it because we ended early.
Oh, so they didn't talk about them at all?
No, I don't think so.
You're going to have some catching up to do. So your homework tonight is to YouTube rational functions and get caught up. I'm just kidding. I'm just kidding. So what's the root word of rational?
Ratio.
Ratio. And a ratio is just a fraction. So you see I have a fraction. Numerator, denominator, polynomial over polynomial. You could graph this. This is just a transformation of this. So hopefully you remember your transformations, right? So here's the most basic, it's called a hyperbola. It's our basic rational function. We can shift this, right? Shift it left, right, up, down, stretch it. So we can have variations on them. But you should know from Algebra 1, if you see x squared minus 4, your brain just wants to naturally do what?
Simplify it
Simplify.
to x plus 2.
What does that factor into if we simplify that?
X plus 2, x minus 2.
Plus 2x minus. From your algebra training, what does your brain want to do now?
Cancel out the x minus 2's.
We divide those. So this divides into this one time, and 1 times x plus 2 is x plus 2. Hey, I can graph that, right? At least I hope you can. So how do I graph 5y plus 2?
What was the question?
How do I graph y equals x plus 2?
Oh, it's just y-intercept of 2 and a slope of 1 over 1.
So I go to my y-intercept at 2, slope of 1 and 1. And 1 over 9, right?
Yeah.
And I say, no, we're missing something. We're missing something. We have a denominator, right? I mean, we divided it out, but in our original function, it's there. So what do we know about denominators when we divide things? We have to be careful when we divide. We can't divide by what?
0.
0. Thank you. I mean, we're not allowed to divide by 0. So if I can't have 0 in the denominator, I know that x cannot equal
0.
uh,
I mean 2.
2. Very good. X cannot be 2 because 2 minus 2 is 0 and we can't divide by 0. So if x cannot be 2, then you see there's going to be a hole in the graph right there. And this is what we call a removable discontinuity. We remove that point. That point is gone. Right? I cannot get to the point 2, 4. 2, 4 is not on this function. So 2 is not in the domain and 4 is not in the range. How do I know it's 4 algebraically? Well, after I remove that 0, if x was 2, what's 2 plus 2? 4. Okay. So this is a trick that you should get used to. This is a sneaky trick we use in calculus all the time. That's how we're allowed to divide by 0. Okay. Any questions on that one? We're talking about removable discontinuities, infinite discontinuities, and one more. I believe somebody mentioned this earlier. Maybe you did get to these. I'll get to you. So let's say this was your function. And it is a function. You draw a vertical line. It only crosses one time. So if your function looks like that, this is called a jump discontinuity. So you'll see these in piecewise functions. And that's going to be your homework pretty much. So you're going to look at a function. They'll give you a function. You use Desmos to graph it. You can decide if there's an infinite discontinuity, a removable discontinuity. So you might have to do a little bit of algebra. Or if you see a jump discontinuity, it's probably from a piecewise function. And identifying domain and range. Any questions on any of that notes?
How would you write the domain and range for the removable discontinuity?
How would you rate the domain and range over here? Excellent question. Those might be, let's see, I can put it here. So domain and range. So if this was your homework question and they asked about domain and range, we already showed that 2 is not the domain. It's good everywhere else. If you graph it, it's linear. There's a hole there. So that's the only number not in the domain. So we could say negative infinity to 2 and then to infinity. So if we use interval notation, It's pretty much the same thing, infinity, but we use this little break here to show we're not including the 2. Remember, parentheses means not included. We do the same for the range,
But with 4, right?
but with 4. Yeah. So we're showing that 4 is not in the range. And there's lots of ways to write domain and range. I'm not sure how the back of the book shows you. You can write it as a set. So you could say the domain is x is such that x is not equal to 2. You could say all y such that y is not equal to 4. So I don't know what the back of the book has. But good question. And here it'd be similar, it'd just be with zeros. So here your domain is pretty much the entire number line except for 0. We have a vertical asymptote here on the y-axis. So I cannot use x0, and you know that because x is in the denominator. If you put 0 in the denominator, 1 divided by 0, you can't do it. So
Can the y be 0 on that one too?
the y could not be 0. So that one,
Okay.
domain and range look the same. So good question. So it would look exactly like this, but you would replace 2 and 4 with 0, 0. Since I can't get to 0 this way or this way. And for this one, you would need to know the values here. So you would have a gap in your y's, but x's would be all real numbers. You're defined everywhere on x. You only have a gap in the y's. So hopefully that makes sense. Why can't it be 2? Christian asked a question. Why can't it be 2? Over here? Is that right, Christian? Is that what you're asking about? Well, you guys are making my job hard today. Yes, that's what you're asking about. Okay. So we talked about a fraction. We learned way back when that when we have a fraction, we can't divide by 0. So I can't let the denominator be equal to 0. So the value that makes it 0 is 2. So x cannot be 2. Because if x was 2, 2 minus 2 is 0, and now I'm dividing by 0, which is not allowed. So x cannot be 2. So we remove 2 from the domain. Now I showed you if x was 2, 2 plus 2 is 4, then 4 would be the value or function. So the range, it can't be 4. There's no way this will ever equal 4. So hopefully that answered your question. Good questions. Any other questions on this? Why is the range 4? So the range isn't 4, the range is everything. Remember, the range is your y values this way. So the range can go from all the way down here to infinity, all the way up. But it can't be, 4 is not included in the range. Right? There's a hole there. So there's a hole right there at this point. So because x cannot be 2, y can never be 4. Because if x was allowed to be 2, 2 plus 2 is 4. But since we can't allow the 2, we can't allow the 4. Okay? There's no way to get to 4. Hopefully that makes sense. All right. Any other questions? I'm not hearing any, so